organizers who prepare the challenge titled Efficient Workspace HDR and Installation. I also would like to mention that some part of organizers are working in Samsung electronics, especially in mobile department, including. Okay, so let me give you a brief overview of this challenge. I think there are 4 keywords where one there is an error in category. So the first keyword is burst. It means there are multiple inputs which are captured in a short time in a group. So participants are required to combine those input images to make clean counters. And the second keyword is about HDR. It means there are various levels of exposure time. So there could be saturated pixels or extraordinarily dark images, and participants are required to combine those information to construct a clean image. And the third keyword is about diffusion. It means the input frame follows the Bayer pattern, which means it has only one channel, so either one R or G or B channel value is known, and we need to construct a full RGB image. And the last keyword is the restoration, and it just means the noise. So input frames there is a lot of noise in the input frame, and we need to construct a clean RGB image from the noise input. And this is the let me give you more detail for this challenge. In modern mobile cameras, HDR fusion is typically implemented through multi-frame processing. It means, for example, here the figure shows 3 levels of exposure times from the low exposure time to high exposure time, and the mobile camera, the software in the mobile cameras combine this information to construct a high dynamic image. And this approach faces 3 main challenges. The first one is frame misalignment, which means there is a small time between each input frame, so the frames are slightly misaligned. And the second point is that there are varying levels of noise and blur because of the different levels of exposure time. And the third one is to be implemented on mobile devices. It is important to construct an efficient solution in terms of both speed and memory usage. So the main objective of this challenge is how to effectively utilize the information from multiple input frames while considering the unique properties of each frame. Let me demonstrate the data set. The organizers provided an over-synthetic data set for the multi-frame HDR fusion test. This figure is an example of our data set, which consists of 300 scenes, and each scene comprising 9 misaligned layer input frames, as it shows in figure C. And these input frames captured at 3 different exposure levels, which appear different levels of noise. And I said that these frames are misaligned, and it is implemented by applying local motions. For example, translation, rotation, and blur, and zoom in and out, etc. And further, there are 2 constraints in this challenge, because we are looking for efficient solutions which can be implemented on mobile devices. We impose 2 constraints in this challenge. The first one is the number of model parameters would be less than 30 million, and second, the number of operations to synthesize whole image of this given size would be less than 4.0 teraflops. So the criterion is the solutions that violate these constraints are disregarded, and the winner is determined solely by DSLR and the processor. And this is the graph of the submission from the participants. There were totally 217 participants registered this challenge, And finally, 16 submitted fact sheets and their final results to the organizers. And let me first show the quantitative result first. The first, the teammate Envision AI recorded the highest PSNR value, which is 43.22, and also reached the highest SSI use. And you can notice that they utilize close to the limitations we imposed in this challenge, which are close to 30 million number of parameters and 4.0 platforms. And the team in second place is DKS, and they utilize relatively small resources, both number of parameters and platforms. This is the qualitative results from the participants. We first noticed that the higher PSNR value will lead to the qualitatively better results, which shows the validity of this data set. And this is an example of the participants. And I think we are impressed that images are successfully restored from the noise input across misaligned frames and different brightness levels. For example, in the upper frame, here you can see a lot of noise in the upper frame that in the participant result, they did restore detailed shape and the color of the image in the counters. I think this is one of the most important parts. There's some problem here. This is actually the figure of the winner of this challenge. They introduced another model called FADA, which is abbreviation of flow-based enhanced thermal alignment, and it recursively extracts information from the brightest images to the darkest images. And the next insightful idea from this team is that the aligned model was trained first, followed by training the restoration model. So there are two phases in the training time. So in the first phase, the alignment model was trained, and in the second phase, restoration model is trained while the trained aligned model is processed. And this is the method from the second phase. They introduced optical flow alignment to a hub, which consists of a shallow CNF and a pre-trained SpyNet to compute the optical flow. So these frames are aligned in this step. And to reduce spatial resolution, they also utilize space-to-depth operation to input layer frames. That's all, and let me conclude my presentation. Out of 270 participants, there were 16 who submitted their final request to organizers. The participants proposed several globally insightful ideas to solve this task, and successfully restored the ground truth images. I think these approaches could potentially be applied in real-world industries. Okay, this is the end of my presentation. Thank you for your attention.
You also mentioned as for the NTIRE, there's no difference between the non-color and the color. But how will this metric quantify the noise between the non-short?
Would you say that again? Sorry.
So, non-color they have a higher SNR, and short color has a worse SNR. But you use SNR to quantify that. How do you actually? Really fire or not?
Actually, we just in human sense, there is no numerical measurement time. We just observe this was the just and ground truth, and we just compare those features.
We were in chat.
Yeah. both of them, I think.
So both DSLR and the side computer NTIRE, HDR photo allows perceptual manipulation.
Actually, I think there is no difference between the commonly used PSNF. Ground truth image was synthesized by HDR from the 9 different level response time, but participants were given only several specific level of response time. And I think there is no difference between the PSNR we usually use them.
So if you think about it, it's a different term because DSLR, the HDR domain is perceptual image. So differences at brighter pixels will be marked as much more visible for those pixels.
Yeah.
So it will become kind of a license for what we don't know.
Yes, it's right, but that is the way we choose to numerically compare the participants results because we are organizers and we need to rank all the solutions. But I think the metric would be improved in the future.
Does the data set contain the local motion and how it goes into activity?
Yes, the data set includes the locomotions and we apply several kinds of locomotion like translation, rotation, blur, and zoom in and out.
Is there any evaluation on those things?
Anyway?
Evaluation on those things region?
I think there is no evaluation, just these are types of locomotions we apply.
Okay, so if we don't have any questions, thank you very much. We are